Welcome to the sixth lecture in our Lawrence Tech College of Architecture and Design virtual lecture series. My name is Emily Kudel, and I'm happy to introduce our speakers today on behalf of the Lectures and Exhibitions Committee. Today, we'll be hearing presentations by the winners of the Seed In, Seed Out awards at CoAD, Ralph Nelson and Aaron Jones. And unfortunately, the other winner, Lillian Kroom, is not able to join us tonight. All of these are faculty members at the College of Architecture and Design. CoAD views the overlap of design, technology, and practice as fertile territory for the investigation of education and research. CoAD is working to support research within this overlap so as to better equip designers and design educators to adapt well to our quickly evolving design ecosystem. These targeted awards fund projects that put forward a compelling vision as to how these issues might align through design in the form of creative teaching or creative practice, scholarship, or research. And so the two projects that we'll be hearing about tonight, first is Precast Prototypes, which is a Seed Out grant. Ralph Nelson with Danny Jung, and sorry guys if I'm mispronouncing your last names, Danny Jung, Kevin Piotrowski and Ethan Sword, Greg Karkstra and Zach Morrison. Precast Prototypes is a project to develop innovative commercial building prototypes that employ precast concrete elements as the primary construction system. A primary goal of the project is to develop prototypes that maximize evocative aesthetic qualities within strict economic and performance parameters. The work is guided by the principle of maximum effect through minimum means. The second project that we'll be hearing tonight is webmodel.space, which is a Seed Out grant with Aaron Jones. And he was working with Nathan Ix, Vlad Chertik, Nick Crawford. And this project is also supported by Noir Technologies and the New Museum, New Inc. Webmodel.space is a project which documents significant liturgical structures within Detroit, Michigan with LiDAR scanning technology and ultimately provides new engagement scenarios through prototypical media structures, point cloud visualization, and Dymaxion style mapping. So thank you all very much for joining us tonight. We're going to start with Ralph Nelson. And so you can start screen sharing, Ralph, and take it away.
All right, is that coming up for everyone clearly? Thank you, everyone. So the origin of the Precast Prototypes project came on Telegraph Avenue a couple of years ago. I was driving along behind this humongous precast double T, and I pulled up alongside the truck and it said Kirkstrip Precast on the side. So I figured at some point I'd be able to learn more about this amazing 5 times bigger than my car element and find out exactly what Kirkstrip was. So when it came around to figuring out an idea for the Seed Out grant through CoAD, I definitely thought of Kirkstrip because I was interested in doing something with precast concrete for sure. And we wanted to frame the grant around this nexus of design, technology, and practice. We definitely wanted to have this connection between academia and industry, but I'd really say one of the primary academic goals of the project was really structuring a much closer link between academia and industry for students and having that student engagement directly with industry, and also reinforcing student and faculty collaboration, primarily in practice-oriented ideas. So the project was basically built around this confluence of design, technology, and practice to try to demonstrate an opportunity for innovation and excellence in, I guess, building types that typically don't exhibit the most creative solutions. We see a lot of precast in parking garages and this kind of thing, but not necessarily to remarkable works of architecture. So fundamentally, Precast Prototypes was framed around this speculation on a new era for precast concrete, what I would call a renaissance for the industry. So assembling the team, Emily already listed the team members, but basically I talked to Danny, Kevin, and Ethan, and they had just gone through an ID3 class with me. And say that they didn't know much about precast concrete, but they were game to try out the project. And then, fortunately, I was able to meet Zach Morrison, who's been a fantastic connection at Kirkstra, and really appreciated having Zach work with us on the project. So once we formed the team, the very first thing we did was drive to Western Michigan to Kirkstra's main plant in Granville, Michigan. So they're way over on the west side of the state. They've got like a 50-acre campus and these amazingly giant buildings. And we all took a tour of their facility, including the 300-foot-long casting beds for their hollow core plank, these amazing casting beds for wall panels that are all fully integrated with insulation. You can actually get fully integrated wiring in the panels. I found out where those double T's were cast, so they've got these giant casting forms to make these incredible structural elements called double T's. They have this interesting stair casting machine. You can adjust the treads, risers, angle of the stair. Also, they have some pretty incredible formwork that they do. Pretty much anything you can imagine, they can fabricate. And then one thing that really intrigued me is coming across this, what I thought was just a place to kind of dump their extra concrete after they were casting some more important pieces. But as it turns out, this they use every bit of concrete that that they produce, and these forms create these cyclopean masonry blocks that also, you know, have they can be sold on the market. And they also use them in their casting yard. But I just actually was really intrigued by these elements, and later on I'll talk about a project that wove this idea into it. So after we took the tour of the plant, we were just literally like kids in a candy shop. We were amazed at all the different elements and pieces lying around, and also just the modes of production. We were very inspired from a design perspective on that. So we immediately sat down with a number of people at Kirkstra, including Zach and Greg, but also people who are dealing with marketing and engineering. And we really wanted to find out from them what parameters we can frame for the project from their perspective, so we understand what the needs of practice are as we frame the research and design project. So a couple of things stuck out to us. This is quite a long list, but one of them was they wanted us to think about designing projects where they would use a minimum of 100,000 square feet of precast elements in the project. So these are going to be rather large buildings. We decided we're going to look at buildings that were 2, 3, or 4 stories, as these were pretty common. And we also wanted something we brought to the table. We actually wanted to introduce strategies for daylighting in precast concrete, because typically precast concrete buildings, daylighting is not front and center in terms of an approach to design. So once we set those parameters in place, we actually came back to LTU. We got Carl gave us a little space in the architecture building. And so we set up our little precast studio and started to do some fundamental research and some initial design thinking on the project. Out of that initial design thinking came a set of principles. Emily mentioned the first, this idea of using a minimum means to maximum effect. And that was established in response to the potential of fully integrated precast buildings to utilize a minimum of elements, but each with an essential and visible role. So this idea that you can create something from a small number of elements was really important. We had another principle that arose, clear expression of the element forces. So precast concrete has the ability to define element form and profile in relation to the physical forces that are channeled through each element. So there's really great potential within the precast industry to further develop and refine those elements to both minimize material use, but also optimize the expressive character for architecture. And this simple fact, the concrete starts out in liquid form and adapts precisely to any formwork as it becomes solid. It offers both pragmatic as well as aesthetic opportunities for design. The last principle, elegant proportion and character, that sort of emerged in response to Chicago architect Louis Sullivan's assertion that American architects might concentrate acutely on the production of buildings well-formed and comely in the nude. So this idea that you can create buildings from precast concrete that have this great potential for raw and direct expressive power was something we were very interested in. So this idea that a building system would allow the bare bones of the skeletal structure and then the deep skin of the enclosure to carry some high aesthetic content while meeting the pragmatic conditions of the environment in use was really intriguing. So we actually made a schedule for ourselves, and we decided we're going to explore what we determined were going to be precast types, which is basically what, using a finite number of elements, what buildings do you realize with that? And then we would do variants that would be 2, 3, or 4 stories, but also variants with different ideas. We set a schedule of about 12 weeks, and we decided we were going to do a total of 36 buildings, so 12 types, and then 3 variants off of each building. So this is the first 4 that we addressed. We started to have some interesting ideas coming out of this. We were experimenting with different relationships of these elements and how that defines the space and form of each building. As we went to the next 4, we got a little smarter about what we could utilize and how we could be a little more expressive with those elements. And then by the time we got to the final 4 types, we were kind of hitting the ground running with some really interesting and creative ideas. So basically we did the project in over about 12 weeks. So it's basically 3 buildings a week, which is, I think, kind of impressive in terms of output. So we had a naming convention for the types and variants, and that came out of the NATO phonetic alphabet. This idea that the origin of precast concrete construction for buildings actually occurred just after World War II in this military industrial complex that sort of took over the United States. And really precast elements for buildings is a very new technology. They really weren't done until the 1950s. And it was also a result of the big transportation network that was constructed in America at the time. So that the naming convention was in response to this larger context. So we'll talk briefly, describe briefly 12 of the variants, and I think Kevin is going to start us off here with Alpha. So go ahead, Kevin.
Yep. So this is Alpha. Alpha is a 3-story variant with 14-foot high levels, floor-to-floor heights, and there's a combination of single height and double height interior spaces. The building is 80 feet by 336 feet and is constructed with 4 basic precast elements. The structure is composed of double T's, which span 40 feet, and then they're supported by vertical bearing walls on the interior and exterior. The enclosure on the long east and west sides is of structural insulated wall panels, and these have vertical fins, which help to animate the facade through a dynamic interplay of light and shadow. The glazing is inserted between these fins and the wall panels, creating an overall rhythm of solid and transparent surfaces when you view straight on. The enclosure on the north and south ends is recessed to create sheltered points of entry and shade. A warm earth tone pigmentation is noted in the kind of detail shot that shows how the concrete can start to take on and be reflective of the surrounding environment. So this is Bravo. Bravo, you'll notice, is a 4-story variant, and it also has 14-foot high levels. The building is 80 feet by 320 feet long. and is constructed with 4 basic elements as well. The primary horizontal elements are Varandale trusses, which span 80 feet and are support 40-foot or 14-foot hollow core plank. And the columns then support the trusses, and they're located around the perimeter, where they also double as support for the exterior cladding. So the enclosure that you'll notice on the long north and south sides is comprised of precast panels which span between the columns. There's these precast hoods that are then added to the south facade to help shade the glazing areas that are inserted in those panels. And this hood element is actually repeated on other locations across the facade. So you'll notice that the stairway at one end is created with those same elements placed closely together as louvers. And then on the short east and west ends, these hoods are then rotated so that they act as vertical fins, which responds to the change in orientation that that side has, but also in order to span between the floor structure, floor to floor. So this is Charlie. Charlie is a 2-story variant, and it actually has, the first floor is slightly taller at 21 feet. The building is 140 by 286 feet, and it's constructed with 5 basic elements. It's a column and beam structure, so it supports hollow core plank with column and beams, and these span 26 feet. And so the repetition of this relatively small base size, it's actually 20 by 26 feet, allows variation even within this standardized plan. And so the elevated roof monitors internal courtyards that help add spatial dynamic to the building, and it also brings light onto the interior within this flexible plan. And then there's also enclosure on the long and east and west sides. It's comprised of insulated panels, spandrel panels with vertical fins, and these fins project beyond the glazing to minimize the solar gain while creating dynamic shadow play. In contrast, the short north and south sides feature recessed openings. There's a sheltered porch that shades the south facade, as can be seen in this main image.
All right, so this is Delta. It's a 3-story variant, and it has 14-foot high levels. It is 108 feet by 300 feet and is constructed with 5 different precast elements. The main structure elements are 12-foot wide double T's spanning 50 feet that are set on a series of precast light walls. The openings in the walls allow users to freely pass between or view into adjacent bays in the structure. One of the defining features you can see is the undulating double T on top of the building, which creates a distinct sawtooth roof generated by stepping light wall elements below. The custom elements at the short end face south, hung from the light walls, and frame the openings in these light walls. These provide a deep relief, interacting with the southern light and creating deep shade and shadow. The entrance on the long side features a deep set aisle shaded by varying upright fin panels that indicate the main entry point. And this is Echo. It is a 2-story variant and has a 20-foot or 21-foot high main floor. The variant is 80 feet by 480 feet and is made up of 4 main precast elements. The defining structure element is the Varandale truss, which spans 80 feet, and these are set on precast columns that are spaced 40 feet apart. This variant is delicate and it emotes a character of infinite horizontal extension. The lightness is achieved through the floating continuous precast elements, which also reinforce the horizontality of the building. And you can see in the perspective, there are 2 major rooftop courtyards that are bisected by 2 major entrances below. Here you can see the building connects to the horizon, where through the courtyards as well, it connects to the sky above. And this is Foxtrot. It's a 3-story variant with a 21-foot high main level. It's 120 feet by 420 feet and is constructed using 6 different precast elements. The primary structural elements are 4-foot hollow core planks that rest on beams that span 24 feet. The beams span between precast columns, completing a square bay that generates the variant's grid-like layout. As you can see, the omission of hollow core planks, the entrance on the south side, create a double high entrance. This contrasts with the mostly covered southern enclosure that blocks the harsh southern light. The east and west sides, however, feature large curved insulated fins that capture light throughout the day. The profile of these fins blocks midday sunlight but sculpts morning and evening light, creating a dynamic curved silhouette throughout the day on the side of the building.
Hey, so this is Gulf, which is like our moody variation. So Gulf is a 4-story variant, but its lowest level is actually below grade. If you look in the section, you can see that the building is entered via a bridge that crosses over an open to sky moat that surrounds the building. Its footprint is 80 feet by 280 feet, and it's basically constructed with only 4 basic elements. So its structure is consisted of the column that are only placed along the longitudinal facades, which supports the concrete barandal trusses, which span 80 feet. So the great thing about the barandal truss is that because it holds the slabs for both the floor and the ceiling, every other level can be completely open and free of structure. And then the other 2 elements are just the cladding sandwich panels that are different for the east and west and for the north and south facades. So what makes Gulf's barandal trusses unique, though, is that the extension of the top and bottom chords creates a triangle profile at the ends. So as a result, the building form has dynamically expresses the profile of the truss as a chevron facet. And then for the next one, which is hotel. So hotel is a 2-story variant and with an occupiable roof level. So this one's footprint is 160 by 260 feet. The structure explores the potential of these incredibly deep 4-feet double T's, which lets it span 80 feet. And these double T's are supported by different variations in the precast light walls. So along the east and west facades, the V-shaped light walls respond to both the gravity and the lateral forces, which creates like a pleated enclosure. So the repetition of the V-shaped light walls also extends beyond the roof level at certain points to create occupiable shaded roof space, and also creates like an engaging roof line as well. Intentional openings are cut out of the V-shaped light walls to moderate sunlight, and it also creates these cast dynamic shadows onto the deep recesses of the double T's. On the south side, a deep porch also defines the grand stair, and a recessed bay on the north protects the service dock. So the next one is one called India. So this one kind of has a more of an exotic feel. So India is a 2-story variant. This one has a 20 feet tall main level with a 14 feet tall second story. Its footprint is 80 feet by 360 feet. So in this case, the columns are not placed at the ends of the trusses as usual, but instead they actually hold the truss. The columns hold the truss 10 feet into the truss on each side. So this allows the top floor to have a 10 feet cantilever that gives the impression that it is floating above the landscape. So as you can see in the interior perspective, the truss webs occupy the second floor and creates like this forest of vertical and diagonal concrete elements that kind of creates like these natural separations in the space as well as natural corridors, while the 20 feet high ground level will contain a monumental open space. So the enclosure on the long east and west side are characterized by highly textured concrete lattice screens that not only cast intricate shadows, but they also create a grand arcade around the perimeter of the building as well.
So Juliet's a 3-story variant. It's got a 28-foot high main level, and the building's 80 feet by 280 and constructed with 5 basic elements. The primary horizontal structure is 10-foot wide double T's spanning 80 feet and resting on beams that span 30. The beams span between sculptural tapered bearing walls, which also contain the precast stairs. The enclosure on the long north and south sides have insulated spandrel panels with linear precast screens on the south face to create dynamic shade and modulate light. The east and west ends have curved vertical fins to minimize solar gain and create the shadows. The building is large, but it appears very delicate. Kilo is also 3 stories, has 14-foot high levels, and this variant is 114 feet by 324 and is constructed with only 3 essential elements. The main structural element is the cyclopean block bearing walls that give the building an ancient presence. The blocks are a riff on the waste blocks that I talked about earlier that we found in Kirkstrad's yard. And these blocks are profiled with deep grooves to carry the horizontal hollow core plank for the floors and roof, and also have slots to receive the precast stair elements. The structural light walls replace interior columns to support the beams, and they create natural pathways through the building. The entries on the short ends are deeply recessed to create shadow and shelter, and precast shading hoods hang over the apertures on the east and west side to both modify sunlight, but also give three-dimensionality to the very long walls. So LIMA is 4 stories, has also 14-foot high levels, and this variant is 98 by 244, and it's realized with 4 precast elements. The most distinct elements are the tessellated vertical bearing wall panels. Each of them are 12 feet wide by 54 feet tall. They face east and west and create a dynamic shade and shadow play over the faceted surfaces with openings in the gap between to let in light. The panels combine to create 5 distinct volumes, sort of like row houses with porches on an urban street. Resting on the tessellated walls are horizontal double T's. Those span 48 feet for floors and the roof. And the interior of the building has a mix of double and triple height spaces. Some are open to the sky as courtyards that are achieved by removing selected double T's in a strategic manner. You can see that in the section. So this makes the tessellated panels appear like waterfalls inside the space. So those are our 12 variants, but I wanted to make a comment. One thing that I've remember distinctly is my engagement with ancient Egyptian architecture. This idea that you can experience architecture with this incredible mass and palpability. And there's always this question of how, with contemporary building construction systems, do you capture that ancient quality or that sense of mass? And I think one of the virtues of using precast concrete elements for buildings in the way that we've tried to with this project is you get these really fundamental primitive qualities in a building by exposing those basic elements. And so just from even an aesthetic point of view, I think precast concrete is maybe the only contemporary construction system that can allow you to achieve these sorts of qualities. So when the project continues, and we want it to continue, we still have 14 more types in order to finish the phonetic alphabet. And we definitely want to work with Kirkstra Precast on this project more, and also with Zach Morrison, because he's been great to work with. So I guess I'd like to turn it over to Zach for a little bit and get his commentary just on what his experience in the project has been, and I guess how he's found it meaningful. So go ahead, Zach.
Awesome, thank you. So working with Ralph and Ethan, Danny, and Kevin has been a wonderful experience on our end. Anytime we can be connected with academia to have an input on, well, you know, what does the real world look like, is a beautiful opportunity. But one of the things that I find is that, you know, the real world is often bounded by the way we think it should be. And so I found that we are able to come together and take what we do and our capabilities, but with your imagination, your creativity, and you're being unbounded by what that all looks like. And I remember when I showed up and they showed me all these the very first time, just being so geeked about how much fun you guys had with bringing this together, and how, you know, what we did was one of the things that I love most about the industry and my involvement in it is that it's this partnership of coming together with your creativity, but then the tangibility of how we do things, that we can partner together, kind of as you see the screen says, of working together with all these elements, but bringing them together. I often find that the industry is driven more in okay, this is what was wanted, now just go make it, and then we'll do it again. But being able to come together to create has been wonderful. This has been, I was very pleased to be part of it, glad to be connected with you guys, and just really proud of the work you guys put in.
Well, we have to continue.
Yeah, we do. Oh yeah, 14 more, I like it.
So we're kind of wrapping up with our presentation here, but I'd also like Danny, Kevin, and Ethan to maybe reflect on what the project's meant to them or what they found interesting in the project. Go ahead, guys.
Sure, I could start. So one of the things I found, very interesting about working on this project is that you start to do the practice of like designing some like fascinating buildings but having only the limitation of certain like concrete elements that are also limited by certain dimensions. It kind of gave me the impression that each element has like these latent potentials to have different expressive qualities. Like for example, in one of the variations you saw was echo with the very long horizontal strips. In that situation, the idea was to try to create this long building that kind of gives off the impression it could go on for infinity. So because of that general concept in mind, then you start to realize that you could use certain precast concrete, for example, like a 40-foot wide concrete panel that in itself is a simple thing, but it expresses that concept. So kind of basically, to sum it up, maybe what it is that through the repetition of these basic precast parts, you start to be capable of designing these very singular and clear buildings, if that kind of makes sense.
Yeah, no, it makes total sense. Ethan, Kevin?
I can go. I think something that really stood out to me with this sort of partnership with CoAD is being able to connect the way that things are fabricated with the way that we design. So the ability to actually go and see their plant and see how they make things allowed us to kind of foresee some things down the road and how is this thing that we're going to design actually get fabricated. I think a fascinating thing with their process, when you look at factories, even though everything is standardized, there's a certain level of like human engagement, whether they're building a custom wall panel formwork. It's like very large. If you've ever done plaster casting, it's large plaster casting, a huge scale. And so the ability that someone has to, even with your simple hollow core, someone still has to go through and mark out like where are the different openings for mechanical, or how is this thing going to get adjusted. So even though something's very standardized, there's also a certain level of adjustment within.
Yeah, no, what Zach had mentioned, introducing the real world aspect of things to the academic world. I think that was sort of one of the main interesting things that I had taken away from it. I know we had to just come off of ID3, as Ralph had mentioned earlier, and we had focused a lot on the sort of tectonics of things. And this was all a different material that none of us had worked with. So I think it was a big learning experience for us just from that point of view, but also, being able to integrate this sort of practical aspect of using the element into the sort of the design process. It was made it for, an interesting dynamic. It was nice to be able to work with a set of, I think Danny mentioned, a kit of parts and having these constraints, but also being able to use those in, like Zach had mentioned, unconventional ways or different ways to make these different designs. I think it's liberating, I think for him and then us as well, being able to see what we're able to achieve with these just standard parts. I think that was sort of the main takeaways, being able to see what we're able to achieve just with what we have at our disposal.
That's great. Thanks everyone for your feedback. I think we're maybe running a little late in our time frame here, so I guess maybe we should wrap up. And I just really wanted to thank Ethan, Kevin, and Danny, and especially Zach too, for just being a great team to work with, and definitely look forward to working with everyone in the future as well. So I don't know if we want to open it up for any brief questions or comments. I know how.
Hi guys, I do have a question.
Please.
Yeah, so I did write it in the chat.
Oh, I'm sorry, I wasn't even checking.
No, that's fine. But so I think you guys did a really good job showcasing the work. I have kind of two questions. The first one being, I arrived a little late too, so pardon me if you guys already ran through this, but I'm curious to know like what you guys imagine the program for these projects and proposals would be.
Yeah, excellent question. So we could have a 4-hour presentation on this. But basically, we decided, and this was something early on, we decided that we weren't going to design for a specific program, but rather create buildings that could accommodate many different programs. It's almost like the building would suggest a particular program. And I guess part of where contemporary construction is going is that you want to make buildings that are resilient and can change easily over time, but still retain their fundamental architectural integrity. So they're not custom built per se for a program or maybe even a site, but they're custom built for flexibility.
Okay. Yeah, and then the second question I had, or rather comment and critique for the presentation, was maybe like as you guys are going through like the narrative for each individual variant, maybe showing a little bit more of like some perspectives on like interior spaces of what you're seeing and what you're describing, because a lot of like the narrative in the daylighting kind of fell through when you couldn't see, and like I didn't know where north and south was just from seeing a perspective shot. So like I don't know, like, and I understand you have a time frame limit to showcase the work, and but it would be really nice to see maybe some floor plans and like a bit more. I guess I'm just curious to see more.
Yeah, well, we I don't know, maybe we'll get all of the work up on one of the digital screens in CoAD or something like this. But yeah, because this could easily be a 4-hour presentation if we talked about the design of each one at length. And all that stuff is definitely there. We have all the drawings. It's just we had a limited time tonight. But thanks for your questions and comments. They're great.
Yeah, sure. Thank you.
Any other question or comment?
So I do have one more question.
Go ahead, Nikki.
I was wondering if it could be a really interesting exercise too, to see how you could use these elements at a smaller scale, and like, so like in like a single family home or something like this, and try to use them on like replicate them that way instead of like in such a massive scale, I guess.
Interesting. Zach, you have a comment on that thought?
Yes, the answer is yes. If I was there with you right now, I'd give you my business card and we'd be setting up a time to do this. I love that. There's definitely a demand in the market right now for the small scale, but more of that very modern, robust industrial look. And so we're actually pursuing that as a company on just on our own right now. And so, hey, if you wanted to pick that up and do round 2 of this while we keep going with the other designs, we'd be happy to do to investigate that, because it is definitely something we're interested in.
Okay, cool. Yeah. Thank you.
Hey, Ralph, I just wanted to apologize. My internet went down just as you were finishing up your lecture, and so I'm back on now to help with any other questions that might happen.
Yeah. Are there any other questions or comments? Otherwise, we can transition into Aaron's talk. Sort of running a little later.
I got a question, if you don't mind. I'm also this next speaker. I mean, I'm curious. I really appreciate the idea of collaborating with industry, and I'm just curious, like maybe from Ralph first. How do you start to identify not only like how do you start to identify the parameters or the constraints within the things that they're making, but then also like understand the room or the space to innovate without, say, like turning the industry upside down in and of itself? Do you know what I mean?
Yeah, well, there's a lot bound up in that question for sure. You know, I think we, in the time frame for our project, we had a big learning curve, and so we tried to be as intelligent, as creative about working within the parameters that we set up that was achievable in the time we did the project. But in a way, the project was just like step 1 in terms of understanding how you can start to innovate within this particular industry. And one of the virtues of the precast industry is everything is highly codified or regularized, and that has to do with the fabrication technologies that they employ. But as that evolves over time, it opens up all kinds of new opportunities for design and innovation. And I don't know, maybe Zach, you want to even speak to this?
Yeah, I think one of the things that's so important about this is that anytime we engage in a building project like this, without collaboration, it's everyone puts out, we have expectations on each other of like, this is what you do, this is what I do, and we're both doing it to each other. But when we can just get in a room together and talk about it and say, how do we make this thing happen? It just greatly increases the opportunity for the directions we can take this and where we can go. And one of the things that I really enjoyed about this is that I look at a lot of these concepts that have been come up with, and I think a lot of them are like, hey, we would never do that. But then I go, well, why wouldn't we do that? Because I've been stuck in where we go. And so I feel like it's like you almost get the two extremes where I could just say, it's like, we're a company, we just want to make money, let's go do this. And you can have these crazy ideas, but it's like, well, how can we bring them together such that we can do something that benefits all of us, that, and then ultimately leaves us with you know, our customers in the end and our clientele with something better that improves their communities.
Yeah, and I don't know if that addressed your questions, Aaron, but we could talk more about that.
Sure. Thank you.
Yep. Thank you. All right. Well, thanks everyone for listening, and I'll, I guess, stop screen sharing here and hand it over.
Who's going next? Me?
Yes.
Yeah, Aaron.
I'm kidding.
I know.
Well, we did intros in the beginning. It's sort of the Pledge of Allegiance here. Can you guys see my screen okay? We have to say this at the beginning each time we share.
Yep.
Thank you. Thank you for the time. So let me, if you don't mind, I'll reintroduce the project since it's been a little while since Emily talked about it. This work that I'm doing, this project documents significant liturgical structures in Detroit, Michigan with LiDAR scanning technology, and ultimately provides new types of engagement through prototypical media structures, point cloud visualization, Dymaxion style mapping. The conversion of analog cultural resources into digital form is known as digital heritage preservation. Though in this case, the work I'm doing and working with students continuously cycles the digital assets that we collect into new physical things and spaces. Two goals within this work are to document and archive buildings indicative of cultural legacies within the city over time, and two, to provide opportunities for expanded engagement and interpretation of these buildings through contemporary technologies and fine art channels. There's, similar to Ralph's point, maybe at least 4 hours worth of stuff here. I've been working on this for a while. So I want to acknowledge the students who have cycled in and out. Currently, Nick Crawford is a graduate research assistant, but he's provided a lot of work in this project over the past couple of years. Nate Ickes, Vlad Chirtik, Rachel Kowalczyk once upon a time, and even Manzi Yang. So those have all cycled through. And though I had proposed the project in collaboration with Noir Technologies, which is based in Troy, and they provided a lot of support with regard to the specific equipment that I used, the project itself on its own terms have been kind of pitched to a few different organizations who have supported it in different ways. So I'm going to present a kind of like a lot of different things, and then it kind of comes together at the end. So like I said, the project itself is called webmodel.space, which is kind of a mouthful, but it alludes to a few different things. One is a premise that this work can be housed, or some kind of like the data that I'm collecting can be housed within a web-based archive, a website. And so the building scans themselves are all gathered together on a domain. So web model, and then also the fact that these are generated from LiDAR scanning technology. So I've advanced this slide, I'm kind of bogged down, but LiDAR scanning technology ultimately provides, produces point cloud based information. And so the name just kind of comes from a collapse of the fact that these things are based online, and then they're comprised of dot spaces. So I got the domain web model dot space. That's how it came about. This has kind of evolved and takes a few different forms. So the idea that some of this archival information is housed online spurred just kind of different tracks. And so some of the things that we're making continue to find a full resolution online. And so these are, not only are we able to kind of look at the building scans, but actually play with them and make new things into what we're calling fidget models. I'll talk more about this later, but here's a little video of my son playing with some of the things that we've made on our LTU laptops here. Some other aspects of the project have just turned into a kind of material research. So how we take the digital assets and translate them into physical things. And in a way, try and take the constraints of the equipment that we have at LTU to issue and produce those sort of things. And so, you know, taking LiDAR scans, turning them into mesh models, 3D printing them out at kind of ridiculous scales. We'll talk more about that too. Physical things in terms of physical models. And then ultimately what I'll wrap up with is how this project essentially frames itself into a work, a specific project, which is going to be, it was meant to debut at a little museum in Colorado this past summer, but now postponed to summer 2021, God willing. So we'll talk about that. Some background, and I appreciate Ralph also introducing his work within the context of design, technology, and practice, some of our sort of operative realms within our College of Architecture and Design. So I'll give like a very fast, not to toot my own horn, but a very fast context of work I do and how this folds into in a kind of practice-based realm. Very typically, I'm working with performance artists, more often musicians, on types of performance infrastructures. And as you can kind of see in this image, very often like the things I make go inside of other buildings. So it's like kind of like small architectures or set pieces which go inside other buildings. Oftentimes the things I'm making are graphic or storytelling mechanisms, and the graphics or the storytelling is derived from the content of those same performers. So it's like infrastructures for certain kind of narratives, so to speak. But all of those full-scale environments come from a studio practice, which is rooted in very typical things like drawings and models and mock-ups and what have you. And taking the models and mock-ups sometimes as having like real agency in the collaboration with other people. So like making a model, maybe even a peculiar model, but using that physical thing as an opportunity to connect with other disciplines and vision additional outcomes or larger scales or what have you. So this is a very simple, this is a small architecture model and a wood grain tool. And it framed a kind of nature of this practice, which I'll tie into the seed grant, which overlaps in residency-based development. We're just making things in kind of art and design residency. So this was an opportunity to scale the tool up and implement that faux finish on architecture scale pieces. Those are sheets of sheetrock. Turn them into prints. And then they increasingly start to fold into larger and larger scale projects. And so this is only really to just kind of talk about how like graphic environments, collaboration with performance artists and musicians and all this kind of it starts for me at a studio practice and at like a drawing and model scale. Here's a small video of a project for the Charles Wright Museum, which used, and so they took some of the curator and some of the other artists that I was working with were inspired by some of the graphic qualities in the models, and we began to use that as an opportunity to vision a prototype for a walk-up greenhouse theater. And it was a way for them to decentralize certain content from the museum into a neighborhood. Faux finish in general, printing in general are like super interesting. I pulled this from on the left from a famous sci-fi film where they're starting to where this person who's come from the past into the future is referencing where he's, he's come from the future now to the past, and he's saying where he's from is off of the growth rings of the trees, kind of using it as a timeline. And so in both cases, just using these ideas of producing at a model scale, like fictional materials in a way, to study different types of, to think about materials in a studio practice as representation, but also as a kind of like ridiculous entree into new collaborative overlaps with other artists, in this case, science fiction. This is an aspect of the work I did in the McDowell colony, which took on portions of WebModel.space. In that, I was starting to, I asked them if I could use the time to develop what I call low poly models. And low poly models, we'll start to expand on that in a minute. But again, how some of that practice just turns into projects, studies, bigger projects, bigger projects. Let's get into the specific stuff. So this is a bit of a pivot, but that I think that practice context is, I hope, helpful. The pivot here is that, I don't know if anyone had heard of this term quadrature or illusionistic dome painting. Our colleague Sarah Cotering told me that, or informed me that quadrature literally means to square the circle. But I'm interested also in this idea of like, of this specific study here, or this specific work is presenting a more expensive and complex dome than could fit within the architecture. So it was a bit of a cheat, kind of a trompe l'oeil, so to speak. And this was employed for a number of reasons, like the dome couldn't fit the structure to support the size of the dome couldn't fit on the site, any number of things. This idea of like presenting building information in a way that was representational but was still occupiable. All of these things are kind of like swirling around. So this is a bit of a pivot. Now, cycle back into the introduction where we're starting to think about documentation of significant liturgical buildings within the city. It's a complicated conversation about what determines significance, I suppose. But immediately I started to identify liturgical buildings because they are so rich with an overlap of liturgy in terms of doctrine, how the liturgy immerses itself or ingrains itself in terms of building form, and then also in terms of imagery or symbolism. So these have become a kind of like type of media structure for sure. And they're ingrained with any number of legacies that I think are indicative of the city over time, not only immigration, capitalism, etc., but they're also just like radically different than I think buildings that we engage with on a day-to-day basis. And so to kind of cut to the chase, I think they're significant in a lot of just like the presence that they provide. And as I've come to know over the past year or two of just engaging with the people who work with or run or sustain these buildings, congregations are diminishing. Their maintenance is increasingly expensive for any number of reasons. So it became a kind of interesting moment to just engage with these buildings. And I found most people involved with them were really like generally very interested in having, so this is St. Joseph's Oratory, built I think around 1880 near our Eastern Market in Detroit. This is a slightly different building, but some of the ways that we had started to scan or document the projects literally on one side is through very expensive equipment, a LiDAR scanner. This is specifically the Leica BLK 360. And so, so expensive that we would rent it. So we had quite a bit of coordination involved in trying to get all these things lined up. And then on the right is a bit of a bootleg kind of version. We call it the ad hoc, where we had photogrammetry software. We had photogrammetry software, a 3D scanner, and then we 3D printed a bit of a harness to connect it to a drone and fly it around. Of course, the results were very different from one $20,000 equipment on the left and about $1,000 worth of pieced together stuff on the right. But interesting nonetheless, and I think it kind of speaks to an LTU character of somewhere in between the two. And that was Nick. This is the Woodward Avenue Presbyterian Church, the first building that we were able to get access to. I found it, this building is privately or owned privately by a company. They bought it because it's adjacent to another property that they're developing. And so they bought it in as a way to just like stabilize the building and also improve their own real estate value, so to speak. And they rent it out for movies. So that's how I came to know it, through just different connections in the city. So like Transformers and other things have been filmed here partially. But interesting in that it was dilapidated and we had quite a bit of access and didn't have to navigate a congregation. So it was an early version of just getting access to a building to try and understand some of the ways that we could work and the work we could do. And then on the right is me up in the cupola, where they would used to have a children's choir sing down to the congregation below. Super scary. This is an image indicative of a LiDAR scan, and I've changed the resolution here to just like really immediately showcase the kind of the qualities of the thing. It's essentially a high resolution like image, but the pixels are held in 3-dimensional space, and with certain softwares you can get additional information off of them, so you can measure them, you can do different things, but they're all made of points. And so LiDAR, if I can, stands for light, distance, and ranging, so different than radar in that way, and it just bounces off light from all of the, so you have to kind of move the equipment around and you piece together multiple scans to get complex 3-dimensional geometry. Using quite a, we're starting to use a lot of different equipment. And so this is an image which is derived not from the scanner, but also from a 360 camera, and produces what's called an HDRI, which is used in modeling to map like a spherical environment. This became especially interesting as now, and I went kind of quick through some of the print work and the modeling work, but to think about like, not just to think about unrolling a 3-dimensional environment into a complex panorama and then modeling it again onto new things, like modeling it again onto domes or models or whatever. And so this is an output of the scan. And so again, a kind of like an early ambition in the work was to like play with a lot of the various assets that we were able to derive. So this is an early scan, and it's unrolled into a kind of panorama. But then once you have those kind of formats, you can start to apply them into more environmental, perhaps even like very simple digital models through what's called spherical bit mapping. So taking the image and then wrapping again around, I think more like basic geometries. So these are just very simple examples of like domes or bells or whatever that start to take imagery, which again has been kind of graphically processed to be a halftone, but like the imagery, and then starting to map it around into a thing. I don't know. So to kind of like to panelize this or to 2D-ify it even further, mapping it onto a 3-dimensional thing like a geodesic dome, a very simple resolution geodesic dome, and then unfolding them sort of like a Dymaxion map of a sphere, like a world or something like that. And so this is, these are just a couple of the pieces which are indicative of like, of a complex scan, which has then been turned into a panorama, which has then been mapped onto a simple low poly, or like a very simple digital model, and then has been flattened out. And then the gray things are the tabs. And so a very early test last year, this is a geodesic dome kit you can buy on Amazon. I think it's called Hubs. And you essentially, what you buy are the connections, and then you make your own cords or whatever. And so we were like more complex than it maybe appears here, but like going back and forth between trying to like print this out and then map it onto a structure was an ambition to then again find new ways of engaging these various building scans. So I put the little buddy there at the top. This is one of the models that was an early study at the McDowell Colony, which was thinking about image mapping and using printmaking, kind of like graph-based printmaking techniques as a way to develop image mapping and that sort of thing. But it translates into a more technical enterprise here, where it's like on the lower left-hand corner is a modeling software called Blender. And then on the right, so it just moves through a lot of different processes. On the right is actually a papercraft software where typically used for people who are making like Iron Man costumes and stuff like that. But it's actually really useful in taking digital models and then turning them into flattened tab-based like cutouts. And it's actually, you can connect that software with things like laser cutters, plasma cutters, whatever, and you can just kind of freak out the scale a little bit and make them really big, make them even building scale. So just some more examples of how that was kind of playing itself out. Again, as different things would come up, or like different organizations would connect just based on like, awareness of a general practice, like, or curators who would ask like, what are you doing? Or what, can we have a studio visit or whatever? This work really filled or played an important role. Last October, about a year from now, exactly, myself and one of the performance groups that I work with closely, we went to Ohio State University and worked in their, what they have called ACAD, which is Advanced Computing Center for Art and Design. And so all of this work that I was doing, all these digital assets kind of dropped into their equipment. And one of the things that we studied especially was like how low poly models mapped with HDRIs and panoramas derived from these scans can also play a part in VR. So just an image of some of the work that we're doing there. But then it's, this is a more sophisticated example, I think, of a dome project here with the building scan mapped into a three-dimensional environment, pushed through a cosplay software and then flattened out at a high resolution. So you can kind of get a sense of St. Joseph's Oratory here now mapped, flattened, and then those little things on the edges are the tabs. So when it folds all together, it starts to tab up. Just some different shots of how it becomes close. There's some, there's some strategy in terms of like changing this into a halftone because it becomes more affordable to print. You can actually screen print it now because it's starkly black and white. There's just a lot of things there. And then also it's just graphically, I think, graphically pretty sweet. On another trajectory, taking the, and so this is just like how, a little bit of kind of shop talk on all of these things. So previously was the trajectory about, I think, image mapping and turning them into panoramas. Now this is also taking the point cloud files and turning them into surface models, which you would think is straightforward, but it's not. It's actually really complex. And so they're almost like they're very different file types. And so starting to kind of coat them or drape them or patch them, there's a lot of different techniques. The image on the right, all of the red or magenta, those are all of the errors within the file. I forgot how many there were, like 10,000 errors or something like that had to be patched. But once it starts to come together, things can, other physical things can start to come out. And so this is a surface model of the scan of the Woodward Avenue Presbyterian Church. The point cloud turned into a surface model. And so once it's turned into a surface model, other things can start to happen with it, which I think are cool and interesting. So on the left, This is an early version. Those are 6 3D printer chunks. They're just printed on the Prusa printers that are in our print lab. So not anything particularly special. I think they can print around like 8 inches cubed. And then on the right is that thing plugged into its larger context. It took a long time. It took a very long time to print this thing out, 50 cubes or bricks or whatever, but it turned into a 1/2 inch equals a foot or 1:24 model. And I'll talk about how that's going to be used in a project in just a little bit. I forgot what I was going to say about this image, but this is, I suppose directly, it's just thinking about how some of those early image and printmaking, image mapping and printmaking technique models have now translated into some of this work here digitally. And so here in the reverse is I turn the ISO curves on just to kind of show the gnarliness and all the poly count of this model. So this is the Woodward Avenue Presbyterian Church in the back, and then a bit of just a study, kind of a playful, weird study of a dome inside the church with a different church mapped onto it. So like a little buddy inside. And then, as I alluded to in the beginning, so we have image mapping towards kind of dome-based pods, so to speak, and then physical modeling through digital surface models, and then also starting to explore some of the web-based engagement. Initially, these things were just housed on the web as a way to kind of essentially view them outside of like software. Like how do you look at a point cloud, for example? And so starting to look at and think about web-based viewing platforms as a way to engage content just became kind of interesting in general. So you can go, let's see if I can go back. On the left is just a video of the website itself, webmodel.space. And each one of those images is a link to the model itself. And then at the bottom are some of the other things. It's essentially what's called a WebGL format, which means it's open and anyone with a web browser can engage these types of things. And we used a specific plugin, which was also open source. Let's see if it'll show. It kind of quickly moves through it, but it has a couple of commands built into it too, so you can actually just measure things and spin around and stuff like that. It's kind of cool. These are additionally, as I started to produce some projects which were getting pitched for exhibitions, thinking of different ways to kind of engage and play with the various assets, again, pushing them out onto the web. These are WebGL models as well. And we started, when I say we, myself and the student assistants, started to refer to them as fidget models because they're really just kind of simple, intuitive, playful ways of just engaging with the work in like really basic terms. Again, that's some videos of my son. They were, what's been really interesting about the project is at certain moments, it's wide open and kind of consumes a lot of different things. And at certain moments, it'll get activated into like these little specific outcomes. It was like, why don't we just kind of try and work on this or pull this off? The web-based aspect was a little bit tangential, but now increasingly with our own COVID scenarios or whatever, it's become really interesting to some of the other partners that I've been working with, as various exhibitions and things like that have kind of moved online. A last bit. I don't know if music comes through. Does music come through? I think I have to have a plug-in. Okay, never mind. So I don't know how this really wraps itself up. It's all in the kind of in the mix here, but as all of this work is happening, Boulder Museum of Contemporary Art reached out and were just generally interested in having a project pitched to them. And so the idea was to have an occupiable dome, panorama building information graphically as like as a graphic kind of environment. And then it would present music with a musician collaborator that I work with named Wajid. Wajid is especially interested in partnerships with exhibition venues, museums, galleries, etc., because he is typically making or producing music in venues like clubs and bars. And so he's looking for opportunities to have a more intimate engagement with his work. And then he's specifically interested in building on or developing themes about the Black church, gospel music, and just various like cultural legacies within Detroit over time. And so these opportunities of like thematic structures, they all start to kind of collapse together into a thing, into a work. And so, yeah. So some of the things that we're developing for the museum, they're interested in a full scale, some kind of full scale thing, hopefully, if people can go to the museum, God willing. And then they're also interested in something within their gift shop. And so I think it's kind of interesting that these, so we're calling it the home dome. And one way or another to have music within a smaller environment that you could buy or take home or pop up or make yourself. And that's the last slide. So it's a bit of a work in progress here. We're not like kind of coming to a clean end. There's a lot of things to take in, but I think in general, some of the things that that I'm excited about in the work is that we're able to incorporate a lot of these aspects, these complex technological components that were like pretty foreign to myself and the students that we're working with, LiDAR scanning specifically. We're able to engage with the city and specific buildings and kind of scan them, document them, play with them, study them in different ways, and ultimately like start to turn them into things which other folks had started to find values in and whatnot. Thank you.
Thank you, Aaron.
Yeah, I'll leave the slides up for now in case anybody wants to see anything else.
Okay. I would now ask if there's any questions out there in this very complex subject matter.
Yeah, it's a little shop talky. If somebody was putting something in, I can't see the chat window either.
Right. There are no questions in the chat window.
I have another question for you.
Okay.
Yeah, it was a great presentation. I'm curious to know what was LiDAR's use before scanning buildings like this?
Well, funny enough, LiDAR scanning and the architecture industry are like very closely aligned, more typically within construction. So general contractors at a certain scale will have deeply ingrained this into their practice already. And in a certain way, LiDAR scanning is kind of like the design industry or the design side of architecture is a bit out of touch to my knowledge. And so very typically, construction industry will use LiDAR scanning for like field measurements, as-built drawings, trade integration, and in really complex, especially in really complex like industrial settings, they use LiDAR scanning, excuse me, to have like complex industrial integration with like various equipment. So the automotive industry, as it pertains to like factories, deals in this stuff a lot.
All right, right. Thank you. Okay.
Mm-hmm.
Well, I guess if there are no other questions, I'd like to thank our lecturers and the teams of people and that they brought with them, and the very, very interesting topics that were discussed. There is one chat question. Here's a question. What's your favorite application of your design style? Creations of drawings, scale models, interiors, architecture?
Is that for me? What is my favorite application of design style?
Yeah.
I just have to say it back to try and think through that. Well, I don't know. If you couldn't get a sense, it's kind of a mess. So like I like to keep things complicated and also interrelated to one another all the time. So I couldn't really tell you that I'm like into a drawing or a model or a thing or whatever. One thing seems to inspire or connect with another thing. And so like the more space, the more kind of plates that I have spinning on sticks, the better in my case, because I don't know, like you can find that like one model will then turn into a thing that will turn into a video. For example, this huge model is going to be turned into a backdrop and a set piece for a music video, for like a similar kind of music aspect, for a musician collaboration. So they're going to fill it with models. They're going to put little tiny set pieces in here. They're going to use it to film, something in there. I don't know. So I would have never thought of that before. But yeah, I don't know. I don't know how to answer that. What do you think, Ralph? What's your favorite design style, model, drawing format?
What's your favorite food, Aaron? I really appreciate your presentation. I always like the way you work, where you're dabbling in different modes and scales, and I think in some ways the representational strategies or media strategies have this profound and direct relationship to the kind of interior spaces and artifacts and architecture that you create. So yeah, I just love the general graphic quality of it all. The graphic quality and sonic quality kind of go together nicely.
Thanks. Well, I wasn't fishing for that feedback, but I appreciate it. I mean, I think in both, maybe to add some complexity to the chat question, I think in both Ralph and my case, even as the work seems maybe purely representational or graphic, there's always an aspiration to be built. And so the idea that like of making things that are occupiable, working towards buildings, or in my case, working towards performance structures or whatever. So even the idea of like, a model can be a lot of different things, but there is really an aspiration to try and find some kind of like occupancy with that thing, or work towards, or aspire towards a larger scale, an occupiable scale.
Yep. Yeah, I mean, a lot of times we do a lot of work in representation because we need to capture the idea and we don't have a couple $1 million to construct it, but we have to capture the idea representationally.
Yeah, I mean, again, another 4-hour conversation of whether architecture is or is not a medium. But if we can think of like architecture as a medium, similar to like maybe a sculptor works on sculptures, there's a distance. And so like architecture is then perhaps like the heaviest, slowest, most expensive, most eco-unfriendly, and any number of other things kind of a practice or a medium. And so like that distance, that distance is productive. So like drawings, models, all that kind of stuff, not only have agency towards like making a thing, but I think increasingly have agency for, maybe in Ralph's case, like have agency for collaboration with industry. So like here's an opportunity to perhaps see an unconventional scenario of like maybe conventional things that you deal or work with every day in your precast industry, or like, or maybe in my case, like to have models or drawings sit on a table and be a collaborative tool for like someone who plays the trumpet to envision a new way to connect their, their work to an audience or whatever. And so I think all of those things are helpful in visioning and whatever, but ultimately like are aspiring towards, I don't know, a next round, a bigger scale.
Okay.
What do you think, Peter?
Yes, Peter, there are no other questions. It is just about time, I guess, that we can wrap this up. Thank you again for this very interesting presentation. I'm going to be thinking about it for quite a long time. So thank you, Aaron. Thank you, Ralph and team. And we'll hopefully get Lillian back when we can. So thank you very much.
Sure. Good night, everybody.
Thank you. Good night.